What's up guys, Kaidom here, and this is getting started with Unreal Engine 4 C++. In the Epic Launcher, I clicked on Launch here. I'm using 4.24, and then this window will pop up, and then we'll create a new project. So we'll select Games here, then Next. Here, we're going to select C++, and I'm going to include the starter content. You can include the starter content or not, depends on what you want, but I'm going to select starter content. And then here you select where you want to put your project. I'm going to put it here, and then I'm going to give it a name, YouTube project, for example. I'm going to click on Create Project. Once your project is created and compiled, Visual Studio will open automatically. So let's head to Visual Studio, and then in our Solution Explorer, you should see your project and name here, YouTube project. This is the editor here, or the engine. If you don't see your Solution Explorer, it should be in View Solution Explorer. And then here we will add the new C++ class or actor, and it will be added here automatically. So let's go ahead and let's go to the editor here. Let's first take a look at our C++ folder. If you don't see the content browser, go to Window here, Content Browser, and select Content Browser 1. And click on here on this Show or Hide the Source panel. You should have the source panel right here, and then click on C++ folder. You should have the folder with your project name, and inside, since we started with the third person template, we have a character here created, and then game mode. So let's go ahead and create our first actor. So I'm gonna right click here and select New C++ class. You can also go from File and then New C++ class. So I'm gonna click on here, New C++ class, and I'm going to select actor. So an actor is an object that can be placed or spawned in the world. So later we will see also how to add components to this actor so we can view something in the world, like a mesh, for example. So click on actor, then next. Here you want to select the name, but first we can actually create subfolders if we want. So I'll click on choose folder here. Then this is the main folder of your YouTube project here, source YouTube project. So if you want to create a subfolder, you can just right click new folder, and I'm just going to call it my actor. And then inside, I can then select the folder, my actors. And when the class is created, it will also add that folder. You can set here the public or private if you want, but I'm going to leave it unselected here. So let's go ahead and click on create class here. Once that's done, you should see here in your Visual Studio that my actor class is now generated or created. So we have our my actor header and my actor C++. And we have some events here added by default and handled here as well. We'll talk about those in a moment. If we go to the Solution Explorer here, we have source. This is our source folder. And inside we have our folder here. And as you can see here, we have my actors folder that I created. And then inside we will find the my actor header file and C++. And in the editor, if you go to C++ classes here, you're going to see the same thing. I have my actor here. Now I can directly place this actor in the world, but since it doesn't have anything to show, well, we will see nothing, but the actor is in the world nonetheless. And as you can see here, my actor 3. So this is your world outliner. If you don't see it, of course, go to Window here and World Outliner. So I can select my actor here and do delete. Let's go ahead and try something simple with this actor. Later, we will create a blueprint out of this actor so we can control it a little bit more. In here, we have our output log here. So if you don't see it, once again, go to Window here, Developer Tools, and then Output Log. And you want to click on Filter, and you want to intick these messages here. So we only want to see warnings. Now we will use this warning category in our C++ project to print or log certain things, like to confirm that something is working or not. Let's go back to Visual Studio here, and in my actor, I'm going to get rid of anything that I don't want. In this case, I'm going to go ahead and get rid of the begin play and tick because I don't need them right now. In my actor CPP, I will also remove this implementation. So we want to take it slow, and I will show you also how to add them later when we need them. This is our constructor of my class. Now, whenever you create an actor class, you will always have the A added. So since we selected my actor, you see that we have my actor. And for structs, for example, we have F structs, etc. We'll talk about structs in another video, but for now we have an actor, and you will always see A in the start here. Now right now in our header here, we have nothing but our constructor here, A my actor. And if I go to the implementation, I can select it here, press F12, or simply go to the C++ folder. Let's go ahead and set the tick to false by default. We don't want to start with the event tick. Since we don't need it, this is going to be a simple actor, so it's always good to turn this false if we don't need it. This is our constructor, and we will use it later to add new components and maybe initialize some variables. Let's go ahead and add some behavior to our actor. So let's go ahead and handle our begin play. So our begin play is a void begin play, and then we will override this function. So we want to override the parent function since our actor also has a begin play that we would like to override. So I'm going to create the implementation for this begin play, and then I'm just gonna go into the my actor C++, and this is my begin play. So when this actor is spawned, this begin play will trigger. So the easiest way is to use our log here. So in this log right here, if you remember, we got rid of errors and messages. But let's go ahead and get errors. Now we only have warnings, so we only want to see warnings here. Now the warning is just a category that we want to use because it's easier to see and it's nice to use as well. So we can write UE_log, and then we want to select the category of the log here. So we want to use the log temp, which is the temporary log. Now this is just a category, and then we want to select the type of the log, which is warning, hence why we chose the warning here. So we only want to show warnings, so we're just gonna print or add a warning message to the log. And finally, you want to say text here, parentheses, and then we can enter our message right here. So we can say, hey, I'm here, or I'm spawned, or whatever. So this is how you would log something in the log editor here, or in the output log here. Now you can add your custom categories, and we'll take a look at that in another video, but for now, this is the easiest way to log something in the output log. Now before we do this, let's not forget to call our parent begin play. Now when you override something in C++, you have the possibility to call your parent's begin play. The way we do that is by writing super double colon and then calling the same event on our actor. So begin play. So first we want to make sure we call the parent's begin play, and then we can do whatever we want here. You can call it last if you want as well. So this is our log temp warning, and then our message here. We can do build solution or F6, or you can do it from the editor. I generally prefer doing it from Visual Studio here, so let's go ahead and do build and build solution. So as you can see here, build succeeded. Let's go ahead and add my actor to the world. Now if I play here, as you can see here, it says warning, hey, I'm here. So if I add another one now, so we have 2 in the world, and go ahead and do clear log here, and then play, you're gonna see 2 actors saying, hey, I'm here. Let's go ahead and remove them from the world. Once again, world outliner, my actors, and then we'll select both of them and hit delete. So our actor is doing something. It's printing something to the log, but we would like to have some more control over our actor. So let's go ahead and add a new component to our actor. We will add a new static mesh component. So I'm going to start by typing class, so I don't have to include the header for the static mesh component. And then, as you saw here, every actor starts with an A. This is standard in UE4. Actors start with A. Components start with a U. So U, and then specify the static mesh component. That's what we want to use. Let's go ahead and add a pointer there. So I'm going to select a name, my static mesh, for example. So we declared our static mesh component. Now we need to create it in our constructor. But before doing that though, we need to specify the behavior in our editor. We want to customize how this component is seen in our editor. So we want to be able to see this component in the editor, in the blueprint editor, and be able to modify it, be able to do some modification on it, such as selecting a static mesh or some other things. So for that, we use UPROPERTY. So a UPROPERTY allows us to specify how a certain item is seen in the editor, as well as maybe some other settings such as replication, etc. So the component can be seen from the blueprint editor, can be seen in the world when you place the actor, then select it. So we want to be able to see it everywhere. And for that, we will do visible anywhere. So we will start with this one, and later we will explore the other thing. Next, we're going to say blueprint read only. So blueprint read only prevents us from modifying this uStaticMesh component variable in the editor, and that's what we don't want. So what we want here is to simply have read access only. So that's why we say blueprint read only for now. And then we can select a category. Now this is optional, but it's nice to select here. So we can do equal, and we can write, for example, components. Now, even though it's a blueprint read only, we want to be able to modify its properties, like setting a static mesh, etc. So we will add meta, then equal, and then what we're going to say here in these parentheses, we will say allow private access. And then we will say equal to true. So this allows us to modify the component's properties even though it's blueprint read only. This is generally the way you want to declare your components. And if we go to the already created character, for example here, you're going to notice that they're doing the same thing. So this is generally how you want to declare your components with a UPROPERTY, so you're able to modify these components in the editor properly. So you have your allow private access to true, and then blueprint read only, very important. Later with variables, we will be able to do other things, but for now, this is how you usually want to declare your components. So let's go ahead and create our static mesh component. So now we will go to the myActorCpp. In the constructor, first of all, I need to include the header file for this component. So what we want to do here is we want to do include components. So components and then static mesh component. Now that we declared our static mesh component, we can go ahead and create our static mesh component. And the way you do that is by doing equal create default subobject. You want to specify the type here of whatever you're creating. In our case, it's a uStatic mesh component. And in here, you can do text and then specify the name of your component. Generally, what I like to do here is just simply select the same name so I don't get confused. Now that we have created our static mesh component, I can go ahead and start initializing some default values. For example, the collision. Let's just say I don't want collision for this static mesh component. I can do my static mesh component and then set collision enabled. In here, it asks for a e-collision enabled. I'm going to write e-collision enabled, no collision. So we disabled collision by default for this static mesh component, but later in the editor, we can override these settings. So this is the initial value, and later we will be able to modify whatever we want in the editor. This time, let's go ahead and compile from the editor. So I'm going to click on compile here, and our compile is complete. Now, what we want to do here is we want to go to the C++ folder, find our actor, and then right click on it and do create blueprint class based on actor. I'm going to select that, and then I'm going to make a folder actually here. So on content, I'm going to make a new folder. I'm going to call it BP my actors, for example. And then in C++ here, do the same thing, right click, create blueprint class. Then I'm going to drop this in my BP my actors. And what I like to do here is always have the same name as the C++ class, but add BP underscore. Let's go ahead and create, click on create blueprint class. And here you will be able to see that now we have this static mesh added. And with the setup that we chose here with the UPROPERTY, we are able to change first, see the component, and then of course change whatever properties we want. If you don't see the details panel, go to window here and the details panel right here. Now we created a blueprint class out of our C++ class. Now if we modify something in our C++ class, we don't have to create another blueprint class. You can simply compile and you should see the changes. Sometimes you might have to restart your project to see the changes, but usually you shouldn't have to. So if I select my static mesh, and as you can see that is the it got saved with the name I chose, and now I can, for example, select something. Let's go ahead and select our cube here, and then maybe change the color to brick. Let's go ahead and compile. Now as you can see here, we got this warning. It's just saying basically that we don't have a root component. That's something we forgot to do. And this is why generally you want to select your output log with warning, so you're able to see if something is wrong with your actor or whatever class in general. Let's go ahead and first set our root component in our C++ here. So my actor C++. So after creating our static mesh here, I'm going to simply say set root component, and then I'm going to select my static mesh as my root component. So it's not a big deal. It shows a default one here, but we did just set it here, so we should be fine. So for now, I can place my actor in the world, and as you can see here, we're still getting that error. It might get annoying a little bit, but after we compile, we should be fine here. So as you can see here, I can play, and same thing. Hey, I'm here, except that now our actor here has something. Let's go ahead and talk about exposed variables. So with every C++ class in general, you will have variables, and some of those variables you might need to expose them to Blueprint. Maybe you want to set something. So a common usage here is to be able to set assets that you would like to use in C++. So in actor, I'm going to go here and start by my first variable. Let's go ahead and say an int32 variable. So int32 is going to be our type here, and then we'll call it my age, and then we'll say 1 by default. Now this is a variable. I can use it in my class just fine. So I want to expose this variable to Blueprint so I can set it. So it's the same thing. Once again, you use UPROPERTY, and then I'm going to say edit defaults only. This is another parameter that allows you to only modify the default value in the details panel. So you could use this. You could also use edit anywhere. This will allow you to edit the variable anywhere. Even if you place the actor in the world, you should be able to select it and then modify the variable like that. But for our purposes here, we will only allow editing default value only. And then for Blueprint, I don't want Blueprint to set this value. I only want Blueprint to read this value. So I will say Blueprint read only. Now, if we select UProperty here and press F12 or find the definition, I'm going to Control F here and say, for example, Blueprint. So as you can see, Blueprint read only. You can read these descriptions here for the usage of each UProperty. Later, you will have also properties for functions, but let's just find Blueprint, Blueprint read only. Here we go. So Blueprint read only. This property can be read by blueprints but not modified. And let's take a look at edit defaults only. Indicates that this property can be edited by property windows but only on archetypes. So you can read these description here is in the object macro. For category, I'm going to select exposed variables. You can name it whatever you want. So this is going to be my age variable that I will be able to set in Blueprint. Let's go ahead and add another variable. This time is going to be a string variable for our name. Maybe we want to give a name to this actor. So let's go ahead and copy paste this. And this time is going to be a f string variable. So our f string is going to be actor name. Let's go ahead and select a default value, and usually you want to use text, this macro for text, for giving us selecting a text, for example. Now this formats your text automatically, and you can also use it with names, etc. So text here, and I'm gonna say nameless actor, for example. Now we have these two variables exposed, and they're both in the same category. They have edit defaults only and Blueprint read only. Now if I have another variable here, int32 for example, some other variable. Let's give it the value 0 here. So this variable right here is not exposed. It doesn't have the U property, and we will not be able to see it in our editor. So back to our editor here. Let's go ahead and close this one so that we can open it again and see if we have the changes. We might have to restart the editor, but for now, let's go ahead and press F6 so we can compile. So build succeeded. Let's go ahead and take a look at our actor right now and see if we have to restart the editor or not. So right off the bat, we have this details panel. Let's just go ahead and click on open full blueprint editor here. And let's go ahead and click on class defaults. And let's find our section or category exposed variables. And as you can see here now, we have the age here. We could select, for example, 25. And of course, the actor name. Let's just select amazing actor as our new name. As you can see, we exposed our variables here. Now, because we set it as blueprint read only, if I look at my age, you can see we only have get my age. We don't have a set. So I can use it in blueprint if I want, but I cannot set it. Now, if we go ahead and change this blueprint read only to blueprint read write. So this time we will select both of them. As you can see here, we couldn't find the some other variable here. So if I look here, class default, some other variable, there is no such variable because it's not exposed to blueprint. So now our variables are marked with read write, and now we should be able to set our actor name, for example. And as you can see, we are able to set our actor name here because now it's marked as a read and write. And as you can see, it preserves, of course, your default settings here, even though you modified the C++ class. Now that we have these variables, let's talk about functions. How can we expose functions to blueprint? Well, it's pretty easy. Let's go ahead and create a new function. So we can make a function to print or log something to the log. So we can do void log something, and then we want to log some string, for example. We can say if string, and we want to pass this as a const if string to log. So this is what we would like to log. Let's go ahead and create the implementation here. So I'm gonna click here, create the implementation. I'm simply going to copy this one. So if you want to log a string, what you need to do here in this macro, you want to do the %sign and then s, and then here you want to do comma and then the string that you want to print. So string to log, and then I want to print the string to log. If you want to print an integer, you need to do like this. So you want to do d here instead, and you can print like an integer, like my age, for example. You can also do if string colon from int, and you can specify something like my age as well. But anyway, for this one, we want to print our string here. So let's go ahead and print the string to log here. So we want blueprint to have access to this function. So how can we do that? In the header here, so the way you want to do it is the equivalent UPROPERTY macro for functions, which is a U function. So with a U function, you can do a lot of things. Maybe your function is a server function, maybe it's a client function, and we'll talk about those in another video. But for now, we want to give blueprint access to this function. So how can we do it? So we want to make it a blueprint callable event, and this way blueprint will have access to this function. And then we can do here, just specify category if you want. This is optional, of course. Just say exposed functions. Now this function is a C++ function. I can use it here. So when the actor here, maybe when the actor starts here, instead of logging here, I can use the log something here instead. Log something, I can do text here, and then print I'm here. And let's go ahead and pass this by value as well. So this is required, otherwise we won't be able to compile. Let's go ahead and compile now and see what happens. So we compiled our code successfully. Now we're using our function in C++, but the most important thing here is that we want this function to be exposed to Blueprint. So we want to call a certain function on a C++ class. So now if we go to our BP_myActor, I can go to the begin play here, for example. So here we use the begin play in our C++ actor, but we can also use it in our Blueprint actor. So let's go ahead and do begin play here. And let's not forget to call our parent's begin play. So the way you do it is by right-clicking here, add call to parent function. So we will call our parent class, and then let's see if we have the function. Now, if you don't see it here, you might just need to restart your editor or a project. Then let's look for log something, and here you go. So we have our, let's go ahead and type here, hey from Blueprint. Let's go ahead and compile here. We have the actor in the world already. Let's go ahead and play. And as you can see, it says hi from Blueprint and our standard begin play implementation, which is I'm here. Maybe we should add from C++ as well there. So this is how you can make a function callable from Blueprint. What if I want Blueprint to do something from C++? So I can go here and do a void. I'm gonna call it BP do something. So this is my function, and I can say UFUNCTION and then Blueprint implementable event is what you want. So a Blueprint implementable event is a function or event that you execute on your Blueprint without needing a implementation. So we don't actually need to make an implementation for this function. We can simply call it, and the implementation should be in the Blueprint. So here in my begin play, I'm going to say, hey, I'm here from C++, for example. And then I want to call a function on my Blueprint, and I'm going to say BP do something. So I'm calling a function or event. It's an event in Blueprint, but let's just say function here since we're C++. So BP do something, I'm calling this function from C++ on Blueprint. Let's go ahead and close that. Let's go ahead and compile now. Now, once again, you don't need an implementation if it's a Blueprint implementable event. And there you go, compiled. And even though we see this warning right here, it says function definition not found. Like I said, because it's a Blueprint implementable event, we don't need that implementation. Let's go ahead and clear our log here. And so we can do BP do something. And here we go. So we have our event here. You're going to notice that it's an event that doesn't return anything. Then we can simply say print something here. And I'm going to say, okay, from BP here. So, okay, from Blueprint. So this should trigger when the game starts. So play. And as you can see, okay, from BP. So we have successfully executed a function from C++ to Blueprint here. Let's go ahead and take at a third type of UFunctions, and it's called Blueprint native event. The Blueprint native event is a function/event that needs to be or should be overwritten by Blueprint. So first of all, let's go ahead and declare our function. So void, and let's say BP native event, for example, or my BP native event, just avoid the same name. And then this is going to be our normal my BP native event. So let's go ahead and do our UFUNCTION macro, and then we can select Blueprint native event. Now the implementation for this is a little bit different because you need the underscore implementation after the function name. This would be your normal declaration, but because it's a Blueprint native event, you need to add the implementation like so. This will be our default implementation in C++. And then we should, in Blueprint, override this event. Now we're going to see a similar thing in another video with client and server events where you need the implementation like this. And of course, IntelliSense is going to complain about it, but it's totally fine. So I could print something here or log something, native event here, for example. Let's go ahead and call this event though from C++. So we will do it after we, for example, log something here. So once we log something, we can do, for example, my BP native event. Let's go ahead and compile. And now I can go back to my actor here. And then I'm going to either click on add new, override function, and I can find it here, or I can simply look for it. So usually just write event first, and then of course my BP event right there. And then we will print something here, and I'm going to say native event from BP, native event from Blueprint, and let's see who gets to call it. So if I play now, as you can see, native event from BP called twice, even though we have this native event here. Let's once again check that it was not logged here. So if I play here, as you can see, we did not get the log here because it was overwritten by the blueprint. Now maybe you want to do both implementations. Let's go ahead and comment this one so we don't get an infinite loop here. So maybe you want both implementations. So let's go ahead and compile here. So the way we do that is we call the parent or C++ implementation as well. So we can right click here, add call to parent. You can either do it right away or after you do whatever you want to do and then call C++. And let's go ahead and do this. But let's go ahead and add the call here for my BP native event. And one thing to keep in mind here is that in begin play from C++, if you want to call a native event, you need to call it before the super begin play. Otherwise it will not work. This is only for native events that are handled by Blueprint. So keep that in mind. So in begin play, we will call the native event and we will see who handles it. Let's go ahead and compile. And let's go ahead and play. So if I play, you see here that native event from BP printed and native event here. So both of them handled the same event, or because we called the parent as well, we are able to get both implementations. If you want to learn more about these UFUNCTION implementations, take a look at this page right here. You can search for UFUNCTIONs and you will get this page right here that explains every function specifier. And we'll be using some of these specifiers in our next videos. So I hope to see you next time. Until then, take care. This is Kaidong signing out.